Welcome back to section 7.3, in which we're looking at the law of cosines. We have this next example right here, and that is of an airplane that flies 180 miles from a point X at a bearing of 125, and then turns and flies at a bearing of 230 for 100 miles, and how far is the plane now from the point X? Well, how do we do this? Well, let's get a north-south line since we're dealing with bearings, and we'll call this point X, and we have 125 degrees, and we're flying down like this. And then after 180 miles of travel, we're going to turn and fly at a bearing of 230. So I apologize, let me draw that a little bit more straight. The fact that those are straight up and down is important. Okay, so let me come back here, grab the pen, make this a little bit longer, and we're going to try to do a straight up down line. And now we got 230 degrees, so that's more than 180. Let's make it right there. We'll call that 230 degrees. And we're going to fly along that one for 100 miles. And the question is, how far are we away? So let me come in here. Actually, let me erase that line that I just drew, and let me come in here and put it in a red color. It's this red line right here that we want to find. We want to find the distance between where the plane started and where it is right now after it's traveled 180 miles and then 100 miles. We want to know that distance d. And so if we're going to have to know that distance d, we're going to have to get an angle. And so we've got to do some creative thinking. So what do we know? We know that it's 125 degrees from here to here, and so we know, let me put it in blue, we know this angle right here is 55 degrees. Now why do I care about that being 55 degrees? Well, if I know that that's 55 degrees, I know the alternate interior angles are equal. So I have two parallel lines, the north-south lines that are dotted, and they're being cut by this black line that's 180 miles long. And because of that, this is 55 degrees right here. Alternate interior angles would be equal. That helps me. That's going to help me get a key piece of information. And I'll put it in red. It's going to help me get this. Now what I know is that all the way around is 360. So let me take 360, subtract away 230, and subtract away 55. And you get good at this by experience, but it is still a little sketchy. Like if I were to leave this for years and come back, it might take some time to figure out, how am I going to get the angle relationship that I need? But 75 degrees is that angle right there. All right. Well, we know an angle, but we don't know the side opposite it. So we're going to have to use the law of cosines. So let's talk about the law of cosines. The law of cosines says take the side that you want, in this case we want d, set it equal to the square of the other two sides that you know. And then subtract from that 2 times those same sides, right? If we could get away from the letters and just talk about what it is, times the cosine, because it's the law of cosines, of the angle directly opposite it. It should be easily just talked through. And then once you have that, we're done, right? We're going to take 100 squared, add to that 180 squared, subtract from that 2 times 100 times 180 times the cosine of 75 degrees, making sure we're in degree mode. And we're going to hit equals, and we're going to have a big number. So we're going to get d squared is equal to a fairly big number, 33,082.5, and it just keeps going. But remember, we're just going to take the square root of that answer, and we're going to come up with 181.88. So d is equal to 181.9. 181.9, in this case, they were flying miles, sorry. 181.9 miles. So if you answered 182 miles, no problem. Both are okay. We're not going to get really worried about the technical rounding there. as we go through. So just a nice application of the law of cosines, one and done. So here we have a weight that's supported by cables and is attached to both ends of a balance beam is shown in the figure. What angles are formed between the beams and the cable? So what we want to find, and I'll keep it in red, we want to find angle A and angle B. Okay, those are what they want us to find. Well, let's use the law of cosines. So the law of cosines would say, well, I'll keep it in the way that I've been talking through it the whole time. There is a possibility of memorizing it another way. But let's just talk about it this way. So if I want to find A, so let me say, come here and say find A. Right? Find angle A. Here's what I know. I know that the side opposite A, 60 squared, needs to be equal to the other two sides, 45 squared plus 90 squared minus 2 times those same two sides, so not even looking back, times the cosine of the angle opposite it. And so you could somehow just go through it and solve this guy. 60 squared. If I just keep the numbers, it's really up to you. You can go fast. You can combine stuff in a calculator. You could solve for cosine A, which is what I was going to do in the future. But let me just take you through this. 90 squared, 8100, minus 2 times 45 times 90, 8100. Right? Yeah, that makes sense. 90 times 90, 8100 cosine A. Perfect. So now I'm going to take the 3600. Well, I'll leave that alone. So you can just clean things up. 2025 plus 8100 is equal to 10125 minus 8100 cosine A. So we'll take the 3600 and subtract away the 10125, or sorry, 3600, and subtract away the 10125 and get a negative 6525 is equal to negative 8100 cosine A. And so cosine A is equal to positive 6525 divided by 8100. And so if we take 6525 divided by 8100, we get a 0.8055 repeating is equal to cosine A. And so we know what to do. Let's do cosine inverse of that answer, and we get 36.3 degrees. Right? As we come through there and find cosine A. Now, what else do they want us to find? They want us to find B. And so they may say 36 degrees in the back, 36.3 is fine. You're going to find B the exact same way. So here, let me just show it to you a little bit differently. As we go to get angle B, we would set it up the same style of way. Let me see if I could do that. So side opposite B is 45 is equal to the other two sides squared minus 2 times those other two sides times the cosine of B. Right? So cosine B and 45 is opposite that, 60 and 90 the other two. Let me not figure them out. Let me just solve for cosine B. It'll be 45. Actually, what if we did it this way? Keep things positive. I'm going to show you a pretty efficient way. You're algebra masters. So let's move this over to that side and 45 over. So I'm going to have 2 times 90 times 60 times cosine beta, right? Because I'm going to add it to both sides, or cosine B, sorry, look like a beta, is equal to 90 squared plus 60 squared minus 45 squared. So I'm going to minus the 45 squared, and I'm going to plus the 290 60 cosine B. That gets rid of the negatives, which is nice. So what's cosine B? It is just 90 squared plus 60 squared minus 45 squared, all over 2 times 90 times 60. You could memorize that as well, or write both forms down, right, since you can do that. So here I don't have to figure them out individually. I'll just take 90 squared plus 60 squared minus 45 squared and hit equal, so it does all that, divided by 2 times, in parentheses, 2 times 90 times 60, and then hit equals. And now I'm looking at cosine b, it looks like a beta, sorry, is equal to 0.89583 repeating. And I'm going to just quickly take the cosine inverse of that answer, 26.3 degrees. So b is equal to 26.3 degrees. And so that's what we have. You know, that gives me those angles using the law of cosines, and it works out really nice. So this is a classic surveying example where you have to go around a tree but get the line marking there. And so what they really want us to do, you can see the layout here, they really want to know this distance that's right here. Let me highlight the distance. I'll highlight it in blue. They want to know this distance of the base of the triangle. See, they can't go through the tree or the bush or whatever it is. And so we do this triangulation thing around it where you can control the angle. So let's go find that. Let me call that length C. Well, that's what we want. Let's see if we can just find it. C squared. Now I don't know an angle in the side opposite it, so I'm going to use the law of cosines. So if I look at the angle that I know, 70 degrees, I don't know the side opposite it. I'm not able to figure out any of the other 2 degrees because I don't have that much information. And so what's c squared going to be? It's going to be equal to the other 2 sides squared minus 2 times those other 2 sides times the cosine of the angle opposite, right? So always minus in there. So just like we've done up here, minus 2, right? Always a subtraction of those 2. So you're adding up and then subtracting the 2ab coming through. So we get nice reinforcement of this formula coming through here. And now we just plug it straight into our calculator. There's really no reason for you to do anything more than plug in exactly what's there. Your calculator do great with order of operations. We're almost done. And then we need to make sure we answered the question. I kind of breezed over what the actual question was, knowing that that was the only missing length that was there. And so I'm now plugging in the last piece, which is the cosine of 70, and hitting equals. And I get c squared is equal to 240.5. And so that's sometimes the problem. Sometimes people will get wrong answers because they give me what c squared is. Remember to take the square root of the answer always. And we're getting c is equaling 15.5. So 15.5 feet is what c is. Now it says use this technique to find the length of the property line. So the length of the property line isn't 15.5. It's 18.0 plus the 15.5 plus the 14.0. So it's 18 plus 15.5 plus 14. And we get a nice 47.5 feet as an answer to the length of the property line. So make sure you're answering the question that's there. So they introduce us to Heron's formula, which is a way to get the area of a triangle if all you know is the side lengths. And so if you know an angle, you can use that fancy formula that's given before, the 1/2 AB sine C, or whatever that was from before. But here's Heron's formula, so they just want you familiar with it. Again, if you're asked to apply it, you would simply go to your notes and find Heron's formula. And Heron's formula allows us to know the area of the a triangle if you only know the side lengths. Okay, and so what it says is if a triangle has side lengths A, B, and C with semi-perimeter, so the semi-perimeter is half the perimeter, so half the perimeter is, in this case, 22 plus 45 plus 31. We're going to find that full perimeter of the triangle, 22 plus 45 plus 31. and we're going to take half that, and that's going to be 49. So S is 49. If you know that, then the area is equal to S, the semi-perimeter 49, times 49 minus one side, times 49 minus the second side, times 49 minus the third side. So semi-perimeter will always be bigger, and Heron figured this out, right? So just some cool thing, so you don't have to find a perpendicular height and go through all the angle measurements. You can take advantage of the three sides that are given to you. And remember, this is any triangle. This doesn't even a right triangle. If it's a right triangle, we're doing 1/2 base times the height, and we're done. But when it's any old triangle, you don't have to drop a perpendicular, figure out the side lengths and all of that. You can simply use Heron's formula. And when you do, you get A is equal to 49 times 27, right? Because that's going to be 27 there, times, what's this, 49 minus 45 is 4, and 49 minus 31 is 18. And so we're going to have that, and now we just have to plug that into our calculator, and you can just go get the square root, and then type in 49 times 27 times 4 times 18, and it'll put everything under that square root, and you get your area of 308.6, right? 308.6 what? Make sure you have units. Inches is not right. Inches squared is. So make sure you have an area unit in there. And that's it. Just some applications of solving with the law of cosines. And so some of the problems are going to just be one and done. Others you're going to have to solve a whole triangle. But just remember, when you're solving a whole triangle, use the law of sines first. Law of cosines first, because you have to. But then use the law of sines to find out all the other ones. It'll be faster.